Here's another moments of inertia through integration problem. So we're given this blue triangle, and first we're asked to find the moment of the product of inertia, about the xy axis, and then we're asked to use the parallel axis theorem to get the same for the x prime and y prime axes. Now, how are we going to do this? So if we integrate with regards to the x-axis as the outer one, then we'd have to have two integrals, right? Because our function changes halfway through. So that'll be one way. Or if we integrate in the y direction, we have a single integral, right? Because we know what the upper and the lower boundaries are. All right, so let's see. Let's find our slopes here, right? So if we say, maybe let's say left. On the left, right? That's this part right here. Our slope is, we start at 0, right? So we can say y is equal to, we'll have to get, after 60 millimeters, we have to be 90 millimeters up. So 90 millimeters over 60 millimeters times x. Let's think about that. If I'm at 0, I'm at 0. That's good. And at 60, I'm at 90. Okay, so that makes sense. Of course, 90 and 60 we can simplify. So that would be 3 over 2x. But we said that we would integrate with regards to y, so we have to find this in terms of y. That's pretty easy in this case. X is just equal to 2/3 y, or just invert the equation. And then on the right, what do we have? Y is equal to, how do we get to where we need to go? We could say, if we start here, that'd be 90, and we need to subtract, we're going downward. At this point, we're x minus 60, right? This is supposed to be 0, right? That would work. And then that has to be multiplied times the same slope, 90 over 60. All right. Does that work? Let's say at 60, that term is 0, so it's 90. At 120, this term would be 60. 60 divided by 60 is 1. 90 minus 1, and 90 minus 90 is 0. Perfect. So if we simplify this, we can get 180 minus 3 over 2x. Solve that for y, for x, solve for y. We get 120 minus 2 over 3y. Excellent. And so now we can go ahead and do our integration. Right, we can say we're looking for ix. And we said we wanted to have the y direction first, right? That's why we wrote everything in terms of y. So we need to integrate from 0 to 90. And then we'd have to do x. Now x starts, like if we look at a slice here, for instance, right? This is our little slice across, and this is where it starts, my integration, and this is where it ends. Right, so that point right here we get from this equation, that point there we get from that. So we start at 2/3 y, that's our lower bound, and the upper bound is 120 minus 2/3 y. Trying to get the moment of the product of inertia, so ix, iy. We said our inner integral was the x, so it'll be dx and dy. I'm not sure why that x does not want to look like an x. There we go. Dx, dy. And instead of going through all the steps here, I think I'm just going to give the result. So if we put that in, then we get 9.72 times 10 to the 6 millimeters to the 4th. My little superscripts today are off, it seems. IXY, right? So that would be our IXY. Now, if we want to get our IX prime Y prime bar, then we first need to know where the centroid is. Well, in this case, centroid is easy, right? We know that it has to be in the X direction, it's symmetrical. So we know X bar is equal to half of that, so it'll be 60 millimeters. And Y bar, what do we get there? Well, it's a triangle, so it's just 1/3 from the bottom. 1/3 times 90 millimeters, so 30 millimeters. Excellent. So I have all that. So then if I think about my parallel axis theorem, it looks like IXY, which I know, is equal to IX prime Y prime bar plus dx dy times a. All right, I'm trying to get the IX prime Y prime bar, so let's solve for that. X prime Y prime bar is then IXY minus dx dy a. All right, so what does that give us? We know our dx and dy are just our x bar and iy bar, so we can plug in here. IXY we said was 9.72 times 10 to the 6 millimeter to the 4th. And then my X bar was 60 millimeter. My Y bar was 30 millimeters. And then, of course, the area is just 1/2 times the base times the height. So 120 millimeters times 90 millimeters. And that turns out to be exactly 0. Now, why is it exactly 0? Well, I know that my Y prime axis is also the axis of symmetry. Right? And anytime I have an axis, one of my axes is an axis of symmetry, I know that my product of inertia has to be equal to 0. So actually perfect that it comes out that way. All right. With that, we solved this little problem, right? We integrated in an interesting way, which is always good. And then we confirmed that the product of inertia is 0 because one of the axes is a line of symmetry.